Matrix was founded 4 years ago in 1999, really with the intent and mindset of the entrepreneurs behind it to revolutionize the RFID business. Matrix focuses on really breaking down very complex problems and delivering them in a very simple framework. The acronym stands for Radio Frequency Identification. In our judgment, RFID will be the single most significant enabling technology to impact supply chain execution in the 21st century.
The idea being that each product has a serial number or an ID, and therefore each item can be then uniquely identified. What we've done essentially is program a chip with 112 bits of ID and error correction code, giving you 2 to the 96th unique IDs to sequentially and uniquely identify every single product in the world.
The breakthrough was people always imagined high throughput read rates and low cost complexity at the silicon level to be a contradiction, and we were able to solve that.
Read rate is critical. You need the fastest read rate possible to make sure that you read all those tags. Our product can read 1,000 tags a second. That capability allows us to read 100 tagged items on a pallet moving through a dock door at 10 miles per hour in 1 second of time. That sounds a little mundane, but put that same tag on a jet fighter and we could read it at 1,000 miles per hour.
Imagine, if you will, you have a wafer that has a size die at about 650 microns on the side. That roughly gives you about 72,000 die per wafer.
Our focus is to take that very competitive RFID technology performance and drive the cost down. The biggest cost item today is the assembly of the integrated circuit onto the antenna substrate. So the key to decreasing the cost of the tag is to get the assembly costs down.
Most people break the production of a tag into several discrete steps. We have taken the process of fabrication of a tag to one bold step.
Instead of going from wafer to tape, tape to flip chip, now you're basically going wafer directly to antenna substrate. The other advancement is we developed a high-speed UV curing adhesive, which allows you to attach the die directly to the antenna and within milliseconds. We're actually talking about putting 1,000 chips attached to antennas simultaneously.
Pica is similar in process to the Gutenberg press. Back in the 1400s, Gutenberg replaced the need to hand print one letter at a time with the ability to print an entire page of text, hundreds of letters simultaneously. But Pica also borrows from today's high-speed web press technology. So much like newspaper printing, with Pica we're printing entire pages of RFID chips onto continuous rolls of antennas.
Just as the Gutenberg press made mass communications a reality nearly 6 centuries ago, Pica will economically fulfill the promise of mass identification.
Let me compare that technology to the existing flip chip technology, which is about 5,000 to 8,000 units per hour. Our vision and capabilities in our prototype will prove that we can do about 1.2 million units per hour to 30 million units per hour, depending on the size of the antenna.
The cost will come down, the technology will become pervasive.